Example 7, graph this function. All right, unfortunately this one was not already done for us in a previous problem, so we're going to have to actually find the vertical asymptotes by ourselves here. So remember, vertical asymptote is where the bottom equals 0. So we need to find two numbers that multiply to 9 and add up to 6. That's going to be 3 and 3. So, you know, it looks like there's going to be a vertical asymptote at x equals -3. That is, unless something cancels on the top, but I don't think the top. I don't think the top's going to factor. We're definitely not going to be able to cancel any of the x plus 3's. So there's going to be a vertical asymptote at x equals -3. Step 2, horizontal asymptote. The degree of the top is 2. And the degree of the bottom is also 2. So if you look at your rules, you have to find the one where it says what happens when the degree of the top is equal to the degree of the bottom. So you've got a horizontal asymptote, and you look at the lead coefficient. So we're going to have the lead coefficient of 2 divided by 1. So there's going to be a horizontal asymptote at y equals 2. So let's go ahead and put those asymptotes in there. Vertical asymptote at x equals -3, and horizontal asymptote at y equals 2. Step 3, plug in 0. So f of 0 is going to equal -4/9. It's kind of hard to graph fractions sometimes, so change that to a decimal. That's -0.4 repeating. So we've got the point 0, comma, -0.4 repeating. Going to be about right there. And now we find the x-intercepts. Step 4, find the x-intercepts. So we want to know where the numerator equals 0. If that factored, this would be a little easier, but that's not going to factor. And so we're going to have to do the quadratic formula. So remember, opposite of b plus or minus the square root of b squared minus 4 times a is 2 times -4. All over 2 times a is 2. So inside that radical there, that's going to be 41. We're going to have -3 plus or minus the square root of 41. All over 4. It's no wonder that didn't factor. It's because this is going to be an irrational number. So once we calculate that, -3 plus square root of 41 divided by 4 is going to be about 0.85. And -3 minus square root of 41 all over 4 is -2.35. About. So you've got x-intercepts. You've got one at 0.85, which is right about there-ish, and one at -2.35. About right there. Okay, so this is going to be a kind of a weird looking shape. Step 5, we're going to see if our graph crosses the asymptote. So you take the function 2x squared plus 3x minus 4 over x squared plus 6x plus 9, and you set it equal to the horizontal asymptote, which was back up here in step 2, so equals 2. So we have to solve that equation there. So what I'm going to do is I'm going to cross multiply here, and so the numerator 2x squared plus 3x minus 4 is going to equal 2 times that denominator, which would be 2x squared plus 12x plus 18. Luckily for us, some things start canceling out there. Those 2x squareds, if you subtract from both sides, will cancel. And so what I would maybe do is we can subtract the 12x over here, get -9x, and add the 4 over here and get 22. So divide by -9. X equals -22/9. -22/9 is about -2.4 repeating. -2.4 repeating. Okay, so that's your x coordinate. So it crosses. It definitely crosses. Your graph is going to cross the asymptote at the point negative 2.4 repeating, comma. Remember what y was. Y was that number right there too. So we've got this weird point at negative 2.4 repeating, comma 2, which is right there. Okay, kind of a weird deal. So what is this thing going to look like? Okay, step 6, we're going to need to make a table. Let's just pick some more numbers. I'm going to do my table going sideways. I know I've got an asymptote at negative 3. So let's just make sure we don't plug in any, let's make sure we don't plug in negative 3. Okay. So what I can plug in is like negative 6 and negative 5 and negative 4. And what I'm going to do, I'm going to use my calculator again. And so I have it plugged in here. Make sure you use parentheses around numerator and denominator. If you hit the graph button and look at it, it looks weird. Okay, this is a weird one, and you can see that it does actually cross. Okay, it crosses the asymptote there. It's hard to see the asymptote, I guess, but let's look at the table. Look at the table, and if x equals negative 6, look at that first y value is 5.5 repeating. So we've got 5.5 repeating at negative 6. At negative 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5.5 repeating is about right there. And then if we plug in negative 5, we get 7.75. So let's call that 7.8. Negative 5, 1, 2, 3, 4, 5, and 4, 6, 7.5, going to be about right there. And if we plug in negative 4, negative 4 is going to be 16, so that's going to be way off the graph. And that's fine, 16. Go back and look at what the picture looks like. And okay, I get it, I see. It's going to do something like this. Okay, so that's about what we expected. The other side, though, the other side's what's weird. So can't plug in negative 3, but we can plug in negative 2 and negative 1. We actually have already plugged in 0. We know what's going to happen at 0. But maybe we plug in, like, I don't know, some other numbers. So if I plug in negative 2, go back to the table there, negative 2 will get me negative 2. So negative 2, negative 2. Okay, kind of weird. Negative 1, plug in negative 1, give me negative 1.25. So negative 1, let's call it negative 1.3. We're just estimating here. Negative 1, comma, negative 1.3 is about right there-ish. And what else we want? Positive 5 is 0.95. So 0.95. Positive 5, 1, 2, 3, 4, 5 as 0.95 right there. Okay, so we've got kind of an idea of what this looks like. Kind of weird. But it's going to approach up here, come down, and come back up. And approach this asymptote from underneath. So that's a weird one. But that's what we've got. Notice it does cross the asymptote right here. And that's it.